Sir,
তোমরা বলবা না আমাকে আমার মাইক অফ এনিওয়ে সো nothing was recorded then. Anyway, let's start once again. So anyway, today we are gonna solve this math. Okay, here is the math. আমার কথা শুনতে পাচ্ছ তোমরা?
জি স্যার এখন শোনা যাচ্ছে।
Thank you. So it is asking us to show that the velocity at any instant is given by dy dt equal to omega into square root of a square minus y square. Okay, so we have to show that this is the velocity of a particle that executes simple harmonic oscillation. So আমরা in our previous class we see আমি দেখিয়েছি যে the displacement can be written as x equal to a sin omega t plus phi or a cos omega t plus phi. So here x is the displacement, and if an object x is displacement is along x direction. But for this book, actually this is a book by Brizlal, simple harmonic Western oscillation by Brizlal. In this book, they are considering the displacement is along y direction. So in this case, the displacement will follow the same equation, y equal to a sin omega t plus phi. Okay, y equal to a sin omega t phi plus phi, where a is the amplitude, same as before. Y is the amplitude, omega
স্যার
is the
আপনার স্ক্রিন দেখা যাচ্ছে না তো।
আমার yes, thank you. এখন দেখতে পাচ্ছি না আশা করি। Okay. Anyway, so here is the math that we have to solve it today. Okay. এটা আজকে সলভ করব যে we have to আমি আজকে যে প্রবলেমগুলো করছি সেটা আমরা যে বইটা ফলো করছি দ্যাট ইজ বাই ব্রিজলাল এর বই, এটা হচ্ছে নেম ওয়েভস এন্ড অসিলেশন, এন্ড আমি এই বইটা তোমাদেরকে দিয়ে দিব বইয়ের যে অংশটা করব। সো হিয়ার ইউ সি আমাদেরকে বলতে হচ্ছে যে the displacement it is a method that is asking us to show that the velocity is written as dy by dt equal to omega into square root of a square minus y square. Here omega is the angular frequency, a is the amplitude, and y is the displacement. Usually in our previous class I show you that the displacement can be written as x equal to a sin omega t plus phi. So here the displacement was along x direction. Our displacement যদি y direction এ বরাবর থাকে, that is if the object oscillates along y direction, equation will be the same. Equation will be the same, only we have to replace x by y. Okay? So basically we are going to use this equation today. So here we know displacement y equal to the displacement y is equal to a sin omega t plus phi. This is my displacement, and then the velocity is basically can be obtained by differentiating y with respect to time, dy by dt. This will give us the dt of a sin omega t plus phi. Okay. So dy by dt is basically equal to, if we differentiate this, a is constant, it will not be affected by differentiation. Sin omega t, if I differentiate sin, it will give us cosine of omega t plus phi into omega t. If I differentiate this thing, this omega t will, after differentiation, will give omega. So basically dy by dt equal to omega a cosine of omega t plus phi. Okay. So this is the value of velocity, but we have to show that this guy is equal to this thing. So now, how to do that? Once again, we know y equal to a sine omega t plus phi. So my sine omega t plus phi can be written as y over a, right? So cos omega t plus phi means what? If sin omega t plus phi equal to y over a, then cos omega t plus phi equal to square root of 1 minus আমরা এটা জানি সবাই না, sin square x or cos square x equal to what? Cos square x equal to square root of 1 minus sin square x, right? So this formula I'm going to apply now. So then we'll get 1 minus sin square. Sin square, we'll get t plus 5. So cos omega t plus 5 equal to square root of 1 minus y square over a square. Because sin omega t plus 5 is y over f. Now what I have to do, I have to substitute this value of cos omega t here. Let's name it 1. Okay, substituting this value of cos omega t plus 5 in equation 1, substituting this value in equation 1, we get dy over dt equal to omega a into square root of 1 minus y square over a square. This is basically omega a square root of a square minus y square over a square, right? Is it clear? The dy by dt equal to omega a, you can write this as like a square minus y square divided by square root of a square, which is basically equal to a. A and a gonna cancel each other, and we get dy over dt equal to omega square root of a square minus y square. So here is the solution. Is it clear? Is this math clear to you? Is it clear? Yeah. So let's try the next math. Here is the next math. For a particle vibrating simple harmonically, the displacement is 12 centimeter at the instant when its velocity is 5 centimeter, and the displacement is 5 centimeter when its velocity is 12 centimeter. We have to calculate the amplitude, frequency, and time period. So, two things. When velocity is 5, then the displacement is 12. If velocity is going 5, that means displacement is 12. Once again, when velocity is 12 centimeter per second anyway, then my displacement is 5. Okay, so this is the case for a particle that is oscillating, simple harmonical. And now what I have to do, I have to find out the amplitude, frequency, and time period for the object. Is this clear? So then, in our previous math, what we did, we derive a formula like this is the velocity. This is dy by dt. Velocity can be written as omega into square root of a square minus y square. So we are going to use this formula here. So we know that velocity, let's say velocity is v equal to square root of velocity equal to omega square root of a square minus y square. Okay. Here you see here omega, omega is equal to angular frequency. Let's name it equation number 1. Angular frequency, and a equal to amplitude, and y equal to displacement. So y equal to displacement. So আমরা এখান থেকে এটা বলতে পারি, দেখো when y equal to 12, when displacement equal to 12, then velocity equal to 5. So when এটি তো বলছে, so when y equal to 12, then v equal to 5, right? তাহলে substituting it in equation 1, we get That is, we have to substitute y equal to 12 and b equal to 5. We get 5 equal to omega square root of a square minus y square means 12 square. So that means 5 equal to omega square root of a square minus 144. Let's name the equation number 2a. Okay, and once again we see here when my velocity v equal to 12, then displacement y equal to 5. Y equal to 5. So again, when v equal to 12, then y equal to 5. So just we have to replace y by 5 and v by 12 in equation number 1. Then equation 1 gives us same thing. When v equal to 12, y equal to 5, that is omega into square root of a square minus 5 square. So that means 12 equal to omega square root of a square minus 25. So this is equation number 2b. Now you see from these two equations, you see in these two equations 2a and 2b, in these two equations 2a and 2b, you have two unknown omega and a. So you can easily find the by solving them, you can easily find the value of omega and a. Actually, that they were asking for amplitude and frequency. And once you know the value of omega, you can easily find out the amplitude. If we solve it, you can easily find out the time period. So let's solve them. So far we got two equations. We get 5 equal to omega square root of a square minus 144. That is equation number 2a. And the other equation is 12 equal to omega square root of a square minus 25. This is equation number 2b. This is clear. And then what we can do, we can divide 2a by 2b. So dividing 2a by 2b gives us 5 over 12 equal to omega square root of a square. This is actually we have to solve it. It is very easy to solve. Omega square root of a square minus 25. Omega and omega are going to cancel each other, and you get 5 over 12 is equal to a square minus 144 divided by a square minus 25. We can take the square root on both sides by taking square root. On both sides, we can say 25 over 144 equal to a square minus 144 divided by a square minus 25. And you can solve them by taking the cross product. 25 into a square minus 25 equal to 144 into a square minus 144. So this will give us 25 a square minus 25 whole square equal to 144 a square minus 144 whole square, right? So this is basically it's like 144 a square minus 25 a square equal to 144 whole square minus 25 whole square. Okay. So basically, if you divide like 144 minus 25 a square equal to, let's say, do it like this, a square minus b square. So to 144 minus 25 into 144 plus 25. This guy and this guy is going to cancel each other. So we get a square equal to 169, or this gives us a equal to 13. So this is basically the amplitude. This is the amplitude. And this is the solution for part 1. This is the solution for part 1. Then amplitude. This is the amplitude. So this is the amplitude. Clear? So this is the amplitude part 1. And then we have to do part 2. So in part 2, they are asking us to find out the value of frequency. The value of, we have to find out the frequency f. So we know, once we know the omega, we know omega equal to 2 pi f. We know that omega equal to 2 pi f. So from this equation, if you put the value of a here, if you put the value of a here, somewhere here, and then solve this thing, this will give us the value of omega. And from here, we can easily find out the value of f. So this is the thing that we will do now. So for part 2, so what we'll be doing is like substitute a equal to 13 in equation 2a. So equation 2a will give us 5 equal to omega square root of a square. A square means 169 minus 144. This is basically equal to omega square root of 25. So that means 5 equal to omega square root of 25 means 5. That will give me omega equal to 1. Omega equal to 1. Omega means what? Omega means 2 pi f equal to 1. And this means f equal to 1 over twice pi. So this is the frequency. It's clear. And then in part 3, they were asking us to find out the time period. So time period is also easy to find out. Once we know the omega, we know time period. We know that time period t equal to twice pi over omega, right? Time period t equal to twice pi omega. So t equal to twice pi, and in this case, my omega is equal to twice. Omega equal to 1. Omega equal to 1. Twice pi by 1. So omega twice pi second. So this is the time period. So this is the answer. Okay, so that means the math is done. So we find out the time period and then frequency and the amplitude for for this condition. Okay. Let's try a new math. So in this math, it is saying that a particle performs simple harmonic motion is given by this equation. So this is the equation of a particle that is giving simple harmonic oscillation. Okay, y equal 20 sine omega t plus alpha. So if the time period is 30 seconds, then if the time period is 30 seconds and the particle has a displacement of 10 centimeter at t equal to 0, find the epoch and then phase angle at t equal to 5 seconds and phase difference between the two positions of the particle at time t equal to 15 seconds. Okay. So this is the equation. This is the equation of displacement that a particle follow when it is oscillating simple harmonically. That is time period of 30 seconds. It has a time period of 30 seconds and that is a displacement of 10 centimeter at t equal to 0. Time t equal to 0 second, its displacement is 0. I have to find out the epoch. Epoch is which one? The value of alpha. Epoch means value of alpha that I have to find out, and the phase angle at t equal to 5 seconds. I have to find out the phase angle at time t equal to 5 seconds. So which is the phase angle? This term is the phase angle. So I mean equation টা আবার একটু বলি সুবিধার জন্য. So for simple harmonic oscillation, for simple harmonic oscillation, the displacement is given by y equal to, let's say, a sine omega t plus alpha, so alpha or phi, whatever. And then here you see y is my displacement. Y is called displacement. A is called amplitude. Omega is called angular frequency. Omega is angular frequency. By the way, angular frequency is omega is angular frequency, and this alpha is called epoch, and AGG termটা omega t plus alpha. This term is called phase angle. Yeah. So this is the various terms involved in the displacement equation of the displacement of particle that executes simple harmonic oscillation. Okay, যে particle simple harmonic oscillation আসছে তার জন্য এই ধরনের টার্মগুলো আমরা ইউজ করি। যে ক্লিয়ার বুঝতে পারলে? এখন তাই যদি বুঝতে পারো আপনাদের জ্ঞানটা সলভ করতে গেলে তাহলে কি বলছে করি আমরা এখানে টাইম পিরিয়ড ইজ 30 সেকেন্ড। সো একটু ম্যাথটা সলভ করার চেষ্টা করি। So here what they give us, give us here displacement equation for the displacement y equal to 20 sine omega t plus alpha. So one thing they told us that okay, if the time period is 30 seconds, time period t equal to 30 seconds, t equal to 30 seconds, and we know that t equal to twice pi by omega. That means omega equal to twice pi by t. তাহলে twice pi by t means 30 seconds. Okay, twice pi by 30 seconds. So এটা বলি pi over 15. Omega equal to pi over 15. By the way, this value of omega, when you will doing the math, তুমি যখন এই ম্যাথগুলো করবে তুমি অবশ্যই এগুলোকে রেডিয়ানে ক্যালকুলেট করবে। আবারও বলি, তুমি ক্যালকুলেটর যদি ইউজ করো, when you use your calculator, তুমি দেখবা যে দুটো অপশন আছে, one is radian and one is degree. অবশ্যই ক্যালকুলেটরকে রেডিয়ান মোডে নিয়ে এই ক্যালকুলেশনগুলো করবে। ওকে, যখন ক্যালকুলেশন করবে। So here then equation is what? One question then we can write the displacement as y equal to 20 sine omega t. Omega means pi by 15t plus alpha. Okay, let's name it equation number 1. So this is the equation for the displacement of the particle. Now let's try to solve the math. At first I have to find out the value of epoch, find out the value of alpha, এবং তার কিন্তু একটা ইনফরমেশন আমাকে দিয়ে দিয়েছে যে when t equal to 0 second then its displacement is 10 centimeter. When t equal to 0 second then its displacement is 10 centimeter. So খেয়াল করো, so we know the equation is y equal to 20 sine pi by 15 t plus alpha. Alpha is my epoch. The condition that was given that, and they told us the condition is at t equal to 0 second, y equal to 10. T equal to 0 second, y equal to 10. সেটাই বলছি, দেখো the displacement y equal to 10 centimeter when t equal to 0. So what I have to do, I have to find out the value of alpha. So what I can do, I can replace t by 0 and y by 10. So if this is my equation 1, then 1 gives us, then 1 become, at this condition 1 become y is equal to 10 equal to 20 sine pi by 15 times 0 plus alpha. So that means 10 divided by 20 equal to sine alpha. Right? Is it clear? Or I can say like sine alpha equal to half, or alpha equal to sine inverse 1 by 2. Sine inverse 1 by 2. I think, what is the value of sine inverse 1 by 2? This should be 30 degrees. So alpha equal to 30 degrees. So my epoch angle is 30 degrees. So this is the solution for part 1. Is it clear? And then in the second part, they are asking for what? They are asking for the phase angle at time t equal to 5 seconds. Phase angle at time t equal to 5 seconds. Now see here, we know that the value of alpha equal to 30. The equation 1 can be written as what? Now, equation 1 can be written as y equal to 20 sine pi by 15 t plus alpha. Alpha means what? Alpha means 30. Alpha means 30. By the way, 30 degree there, radian convert করতে হয়, by the way. Okay, and then is it clear? তোমাদের কাছে জিনিসটা ক্লিয়ার হয়েছে? হ্যালো, আপনারা বুঝতে পারছো ম্যাথটা বাবা? হ্যালো,
জি স্যার, শোনা যাচ্ছে।
শুনতে তো পারবে রে বাবা। আচ্ছা, so actually what we have to do in reality, we have to convert this into radian. তাহলে it is always better to put it in the form of pi by 6. 30 degree means pi by 6. Okay, pi by 6. 30 degree আসলে, কারণ আমি তো বলেছি যে এইটাকে রেডিয়ানে রাখতে হবে, সো কিপ এভরিথিং ইন রেডিয়ান, সো আলফা ইকুয়াল pi by 6 এটা বসিয়ে দিই, তাহলে this is the displacement. Okay, this is the equation for displacement. Now phase angle কোনটা? This is my phase angle. Sine এর argument যে this is my phase angle, so the phase angle is, so the phase angle is equal to pi over 15 t plus pi over 6. This is my phase angle, and in the question they are asking us to find out the phase angle when t equal to 5 seconds. I have to find out the phase angle when t equal to 5 seconds. Okay, so at t equal to 5 seconds, the phase angle, what I have to do, I have to just replace t by 5, pi by 15, pi plus pi by 6. So this is pi by 3 plus pi by 6, and this is basically equal to 6 over pi plus 2 by 3 pi, right? That is equal to pi by 2. So the phase angle is pi by 2 when time t equal to 5 seconds. So that's the math. Is it clear? Let's move forward to the next math. So this is basically the solution. So in this math, it could be easy at a math. A simple harmonic motion is represented by the equation y equal to 10 sine 10t minus pi by 6. This is the equation. This is the equation of an object. Okay, this is the equation for the displacement of simple harmonic oscillation. Okay, and here we have to find out the frequency, time period, maximum displacement, maximum velocity, maximum acceleration, displacement, velocity, acceleration at time t equal to 0, t equal to 1 second. So এটা হচ্ছে একটা পার্টিকেলের displacement যেখানে সিম্পল হারমোনিক অসিলেশন এক্সিকিউট করতেছে। ফর দিস পার্টিকেল আমাকে ফ্রিকোয়েন্সি, টাইম পিরিয়ড এগুলো ফিগার আউট করতে হবে। ওকে, এগুলো ফিগার আউট করতে হবে। তাহলে আমরা একটু খেয়াল করো, দ্য ইকুয়েশন ইজ গিভেন হিয়ার, যে ইকুয়েশন যেটা দিয়েছে সেটা হচ্ছে y ইকুয়াল টু 10 sin 10t minus pi by 6. Okay, and আমরা জানি যে the general equation for simple harmonic oscillation is equal to y equal to a sin omega t plus alpha. So এখানে তুমি যদি খেয়াল করো তাহলে তুমি দেখতে পাবে যে যদি এই দুটোকে কম্পেয়ার করো, if you compare both of them, তাহলে তুমি দেখতে পাবো a is equal to 10. Excellent. So here, if you just compare these two equations, this is the general equation for simple harmonic oscillation, and this is the simple harmonic oscillation. This is the simple harmonic oscillation of a particular object. Now, please compare. By comparing them, you can see that A equal to 10. That means amplitude equal to 10. See here, and angular frequency omega equal to also 10. See here. So by comparing them, we can say amplitude of the object A equal to 10 and angular frequency omega equal to 10. And omega is basically equal to what? Omega equal to 2 pi by t, where t is the time period, equal to 10. So time period t equal to twice pi by 10. So we can say time period t equal to pi by 5 second. Is it clear? And A is the amplitude is in meter here. And by the way, amplitude means what? So you see here time period. So this is the answer for part 2, is time period. So time period is equal to pi by 5 second. This is answer for part 3, part 2. Okay. And in part 1, what they asked for the frequency. Okay, frequency is easy. Once you know the time period, you can easily find out the frequency. Frequency is what? Frequency of inverse of time period. So one solution for one, frequency is equal to 1 over time period. The time period is what? Pi by 5. Time period is pi by 5. So 1 over pi by 5, that is 5 over 5. This is the frequency. And then part 3, they're asking for the maximum displacement. What is the maximum displacement? In your previous class, I already told you guys that the amplitude is the maximum displacement. Amplitude is the maximum displacement. So the maximum displacement is basically amplitude. So maximum displacement is equal to amplitude. Amplitude A, that is equal to 10 meter. That we already solved here. You see that the amplitude is 10 meter and the maximum velocity. And আমরা যদি একটু আগের ক্লাসে চলে যাই, you see here in the previous class we see that maximum frequency is omega A and maximum acceleration is omega square A. So we will use this formula here. So maximum velocity is equal to omega times A. So my omega is what? Omega is equal to 10 and amplitude is also 10. So 10 times 10 equal to 100 unit. And then they're asking us to find out in part B. In part B, they're asking us to find out what? Maximum acceleration. Maximum acceleration is omega square A. So omega is 10. So 10 square times 10, that is 1000. Okay. And then the displacement, velocity and acceleration at time t equal to 0 and 1 second. At time t equal to 0 second, what is the displacement, what is the acceleration, and what is the velocity? Time t equal to 0 second. Okay. Again, we have to find the same thing for time t equal to 1 second. So part 6 is a bit lengthy math. So the equation, the displacement. The equation for displacement is y equal to 10. Teach later. 10 sine 10t minus pi by 6. 10 sine 10t minus pi by 6. Presentation তো বন্ধ হয়ে গেছে। তোমরা কি দেখতে পাচ্ছ স্লাইডটা? হ্যালো,
Yes,
স্যার
sir.
দেখা যাচ্ছে এখন।
জি স্যার দেখা
Yes, sir.
যাচ্ছে।
ঠিক আছে, থ্যাংক ইউ। সো actually we have to find out displacement at time t equal to 0 second, velocity t equal to 0 second, and acceleration for t equal to 0 second. Now the equation for the displacement, general equation for the displacement is y equal to 10 sine 10t plus or minus pi by 6, right? Minus pi by 6. Pi by 6. So at time t equal to 0 second, displacement কি হবে? Y equal to 10 sine 10 into 0, replace t by 0 minus pi by 6. So that means y equal to 10 sine minus pi by 6. So what you can do, you can use a calculator and find the value. I left it for you guys. Okay, calculator use the value বের করবে at time t equal to 0 এটা হচ্ছে displacement. And again, since my displacement y equal to 10 sine 10t minus pi by 6. So what should be the velocity? Then velocity v, velocity কিভাবে পাবো? Velocity v equal to dy by dt. And that means you have to differentiate this thing. So if you differentiate this thing, you will get 10. Differentiating sign will give you cos 10t minus pi by 6 multiplied by 10. I know, I think you guys know how to differentiate. Down later, you did these things in your math 104 course, I guess. So this will v equal to 100 cosine of 10t minus pi by 6. So at time t equal to, so velocity at time t equal to 0, here my velocity is equal to 100 into cosine of 10 times 0 minus pi by 6. So velocity would be 100 into cosine of minus pi by 6. So this is the answer. You have to find the answer and by using the calculator. And they also ask us to find out the acceleration at time t equal to 0 second. So acceleration is a equal to dv by dt. That means you have to differentiate this guy. You have to differentiate this guy. So basically, if you differentiate this, you will get 100 cos ke jodi differentiate koro, this will give you a minus sine 10t minus pi by 6 multiplied by 10. So additional 10 will come here. Okay, and at time t equal to 0, t equal to 0 second, my acceleration will be equal to minus 100, sorry, minus 1000. If you replace t by 0, so this will be a 0 here, sine minus pi by 6. So this is again, you have to find, calculate the value. So these three things, you will see these three expressions. This one will give you the displacement, this will give you the velocity, and this will give the acceleration at t equal to 0 second. And you have to do exactly the same procedure. You just have to replace t by 1 here, t by 1 here, and t by 1 here, and then you will get the acceleration at t equal to, or velocity or displacement at t equal to 1 second. Just remember one thing. Once you put the value here, you have to calculate everything in radian. সবকিছু রেডিয়ানে ক্যালকুলেট করতে হবে এখানে। Here. So let's try the next math. So, okay. So this is another math. By the way, this math is from the book by Resnick, Halliday and Walker, 9th edition. Resnick, Halliday and Walker. Resnick, Halliday book by Resnick, Halliday and Walker, chapter 15. And I think all of you guys have the soft copy of this book. So an oscillator of block, a oscillator consists of a block of mass m 5 kg connected to a spring. অর্থাৎ a spring and a mass that has a or a spring is connected to a object having mass m equal to 0.5 kg, makes a oscillator. Okay, so if you just pull this spring and release it, they are gonna move up and down, up and down. Okay, and you will get simple harmonic oscillator. So they are saying that when it's set with an amplitude of 35 centimeter, if the amplitude of this oscillator is 35 centimeter, the oscillator repeats its motion in every 5 seconds. What does this mean? If its amplitude is 35 centimeter, in that case, the oscillator repeats its motion in every 0.5 second. That means the time after which oscillator repeats its motion is called time period. So this is basically time period. So this is the time period. So basically, and they are asking us to find out the time period. The time period is 0.5 second. So my part A, they are asking for the time period t equal to 0.5 second. This is very easy math. Then in part B, they are asking for the frequency. Frequency is basically equal to 1 over time period. That is 1 over 0.5. That is equal to 2 hertz. C is the angular frequency. Angular frequency omega equal to 2 pi into f. So 2 pi into f is 2. That is equal to 4 pi. And in part D, they are asking us for the spring constant. Spring constant. How to find the spring constant? Tell me how to find the spring constant. Omega square equal to k by m. আমরা জানি এটা omega square equal to k by m. So k equal to omega square m. So k equal to omega square times m. So omega square m. So what you have to do, you have to find out, you have to substitute the value of omega here. 4 pi whole square into mass of the object, radius is 0.5. 0.5. This will give you the spring constant. And maximum speed. Maximum speed is what? Maximum speed equal to কত খেয়াল আছে? Omega times amplitude. So my omega is 4 pi and amplitude is what? 35 centimeter. That is 0.35 meter. 0.35 meter. And in part F, magnitude of the maximum force. Magnitude of the maximum force is basically equal to, in case of spring mass system, আমি বলছিলাম যে force equal to kx. Force equal to kx. So force will be maximum when my displacement is maximum. So F max will be equal to minus k x max. Displacement maximum হলে সেটাকে আমরা কি বলি? Maximum displacement is known as amplitude. K times amplitude. So this is the value of k and here is the value of amplitude. Okay, so you have to put these two values here and this will give you the F max. So there are a few more math. I think you can do it at home. And not only that, in the book from the book by Brizlal, you have to try a few more math from Brizlal. Actually, in the book by Brizlal, there are several math like, let me tell you which one you try. Try math 1.1, 1.2, 3, 4, 5, 6, 7, 8. 11, 12. So try this math from the book by Brizlal. So try. This is the example, okay? Example 1.1 to 1.12 from the book by Brizlal. This is chapter 1 and page. Actually, these are page number. Page number, right? Start from 9. Page number 9. Okay. So these are the homework. So these maths are actually solved. These are the solved math from the book, and then there are a few other maths. No, anyway, that's all for today. So that's all for today. I want to take the attendance. Hold on. So